This is the last of the easy implications. If f is conservative, then it is also path independent. Let's write down mathematically what each of these means instead of using the big words. Saying that f is conservative is just saying that the integral around any closed curve is 0. I think they actually say that work is conservative. I think that's actually how they got that. Path independent would mean start with P or Q, and C1 being some path from P to Q, and C2 being a different path from P to Q. Then what the conclusion here would be is that the integral from C1 along C1 would be the same as the work done along C2. In other words, being path independent means if you have a point P and you have a point Q, then the work done moving something, that F moving something from P to Q, will always be the same no matter which path it takes. So what we want to be able to do is we want to be able to start with two different paths and basically show that the integral is going to be the same. So let's just look at the picture for a second. So here's P, because we're starting with a fixed point P and a fixed point Q, and we're taking two different paths like that, and we want to know that the work is actually the same. Now, this is a closed curve, right? So we're assuming that the work done around that whole curve is going to be 0, because that's what it means to be conservative, right? So we're assuming that the work done along the closed curve C2 minus C1, that's the way they're going to write it, is 0. And then we're just going to work our way through the notation. So this is the work done going C2 forward and then C1 backward. The left-hand side should just be equal to the work done along C2 plus the work done along C1 backward is 0. That's going to be the same thing as saying that the work done along C2 by all these vectors minus the work done along C1 is 0. And then we get to conclude then just by adding, how about if I write down equals 0 so you can read it? Yes, equals 0 like that. And then the final conclusion, just by adding the work done along C1, is the work done by this vector field moving something from P to Q using path C2 is going to be equal to the work done by the vector field moving something from P to Q along path C1. But that's exactly what path independence means. It means that once P and Q are fixed, that the work done by the vector field moving something along either path gives you the same answer regardless. So that's the last of our easy implications.